Hi, welcome to section 5-6 notes on inequalities in one triangle. So the first thing we're going to talk about is the exterior angle inequality theorem. And it says if an angle is an exterior angle of a triangle, then its measure is greater than the measure of either of its remote interior angles. So in this particular case, this is something we talked about earlier in the year, where we said the exterior angle, which is right here, angle 1. Earlier in the year, we said the exterior angle is equal to the sum of the two remote interior angles. So if you think about it, 2, 4, and 3 are all interior angles. They're all angles on the inside of the triangle, where angle 1 is an exterior angle because it's on the outside of the triangle. Now, the remote interior angles would be angle 4 and angle 3 in reference to this exterior angle, angle 1. The way I think of the word remote is I think either of the remote on your TV and you're sitting on the couch with the remote and the TV is on the other side of the room, far away, or I think if somebody's on a remote island and they're, again, far away from everybody. Okay, so again, if we're referring to exterior angle 1, the two remote interior angles are the two interior angles that are furthest away from angle 1, which in this case is 3 and 4. So what we said earlier in the year is that measure of angle 1 is equal to the sum of the two remote interior angles, and sum means add. So we'd say plus, oops, I meant that to be an angle symbol. Measure of angle 3 plus measure of angle 4. Okay, so what the exterior angle inequality theorem says is that, okay, if angle 1 is equal to angle 3 plus angle 4, then angle 1 has to be bigger than 4, and angle 1 has to be bigger than 3. Okay, so that's what we're filling in here. Measure of angle 3 and measure of angle 4. All right. And then we'll use that rule some later. On example 1, it says use the exterior angle inequality theorem to list all the angles that satisfy the stated condition. So on A, it says all angles whose measures are less than the measure of angle 8. So if we look at angle 8, and we can see that it's an exterior angle, then if it first is asking for the small triangle that's right by 8. So I'm going to highlight this small triangle that has 8 as the exterior angle. So again, if 8 is an exterior angle, it has to be greater than either the two remote interior angles, which in this case are 4 and 6. Okay, and now if I look in reference to the large triangle that 8 is an exterior angle of, we're looking at this whole guy right here, then 8 is an exterior angle for these two remote interior angles. Okay, so 8 has to be bigger than angle 2. And 8 has to be bigger than this angle that 7 and 6 combined together. But we've already said it's bigger than 6. So we just need to now include that it has to be bigger than angle 7. We can't say what's bigger or smaller based on what it looks like. We have to have a reason to justify what we're saying. Okay, so now let me erase these markings. And now part B is a separate question. So in this case, it says all angles whose measures are greater than the measure of angle 2. So we go and find measure of angle 2 right here. And if we look at the small triangle that 2 is part of, and we want to find any angles that we know for sure that are bigger than 2, well, we can see there's an exterior angle right here to consider. And we can see there's an exterior angle right here to consider, this angle 4. Okay, angle 4 and angle 1. So 1 looks bigger than 2, but there's no way I can know for sure. If I don't know either angle measurement, I can't say that. But if I look over here at angle 4, because it's an exterior angle to this triangle that I just highlighted, I know that angle 4 has to be greater than 2 and has to be greater than 7. But the question is saying which angles are bigger than 2. So I know that angle 4 has to be bigger than angle 2 because it's an exterior angle. So that's what we're putting here. And then if we look at the large triangle, we'll just do that in a different color. If we look at the big triangle, and again, we want to find an angle that's bigger than angle 2. And if we look at this exterior angle over here, angle 8, we know that angle 8 has to be greater than 2 and 7. But the question is saying name the angles that are greater than 2. And so we know that angle 8 has to be bigger than 2. Okay. So now down here is the side angle relationship inequality theorem. It says if one side of a triangle is longer than another side, then the angle opposite the longer side has a larger measure than the angle opposite the shorter side. So the way I like to think of this is first over here to the right, you can see in my handwriting, I like to name the angles from smallest to largest. Okay, well, if I look at the picture, it's giving me side lengths, but not giving me angle measurements. I can use the side lengths to tell which angles are smallest, biggest, smallest, medium, and largest. Okay, I don't know exactly how many degrees they are, but I can at least order them in that way. The way I like to do it is if 3 is the smallest side, then I know across from that has to be the smallest angle. If 4 is the medium side, I know across from that has to be the medium angle. And 5 is the largest side, so across from that has to be the largest angle. So if I go ahead and put the angles from smallest to largest, then I can see smallest is angle R, medium is angle Q, and largest is angle P. Okay, and then another way to word this question in a different way, it says if segment RQ is greater than segment RP, then what is something true you can say from that? And if you look at those, if RQ is bigger than RP, then I know that angle P has to be greater than angle Q. All right, now the converse side angle relationship inequality theorem is really similar to what we just did. It's just the fact that, I'm going to move this up just a little bit. It's just the fact that now we're using the angle measurements to tell information about the sides. So it says if one angle of a triangle has a larger measure than another angle, then the side opposite the greater angle is larger than the side opposite the lesser angle. So in this case, I can say, well, this is the smallest angle. So across from it has to be the smallest side. Here's the medium angle. So across from it's the medium side. Here's the largest angle, and across from it's the largest side. So if they want me to name the sides from shortest to longest, the shortest side is AC, the medium side is CB, and the largest side is AB. Okay. And make sure you're paying attention to the questions. Sometimes they might say shortest to longest, and sometimes they might say longest to shortest, and you don't want to miss it just because you're not paying attention to what the question says. All right, then this other inequality we can fill in. It says if angle A is greater than angle B, then what's something true we could say about that? And we can say for sure that we know CB then has to be greater than CA based on that. Okay. Now, if you look at example 2, it says write an inequality describing CB and CA. So if we look down here, CB is across from a 40 and CA is across from a 20. So I know that, if I do the small, medium, large, here small, small, medium, medium, large, large, I can tell that CB is greater than CA. It's a bigger side, and remember the alligator chomps the bigger side. So, and the point goes to the smaller side. So that can help you make sure you get the inequality going the right way. Okay, if we look at the back side, just a little more here. On example 3, it says write an inequality describing the relationship between angle ADB and angle DBA. So in this case, they're referring to this angle and this angle. So if we want to write an inequality, I'm going to go and write both of those angles. Okay, and if I look at my picture, I can tell which one's bigger, which one's smaller. I can see that this is the smallest side, so this is the smallest angle. Here's the medium side, and there's the medium angle. So ADB must be greater than angle DBA. Okay. Then if we look at example 4, it says to determine the largest side. So in that particular case, this one's a little tricky. This is probably the trickiest one of the whole thing. Here's the thing. A lot of people would quickly look at this and see that 85 and say, well, across from the 85 must be the largest side, which is LN, and they would go with that. But comparing the angle measurements in one triangle does not work for comparing the angle measurements in another triangle. The small, medium, large thing only works in one triangle by itself. So if I cover up angle LPN, I can do the small, medium, large for the triangle on the right. So I can say smallest angle, so smallest side, medium angle, medium side, largest angle, largest side of that triangle. Now, if we look at the other triangle, I can say, well, this is the smallest angle, so this is the smallest side. Here's the medium angle, here's the medium side, here's the largest angle, here's the largest side. Well, now when we look at it, the question is asking us for the largest side, but if I look at the sides, I can tell this one has a L by it, but it also has an M by it. And I also have the fact that this has an L by it. Well, I can't have two sides that are the largest in the figure. So I've got to decide which one wins, which one is really the largest. And I can't go based on what the line just looks like. I have to go based on the numbers. So in this case, if I look just at the triangle, kind of on the bottom or on the left, how you want to refer to it, the PN is across from a 62 and LN is across from a 61. So you're kind of seeing which one wins out because you can compare those angle measurements within one triangle. And this one ends up winning out, okay, because it's across from the bigger angle. So the answer is PN. Okay, next up, the triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So for example 5, it says determine if the given measures can be the lengths of the sides of a triangle. So one way you can do that is add up any two sides and make sure it's bigger than the third side. So I can say 2 plus 4 has to be greater than 5. I can say 4 plus 5 has to be greater than 2. And I can say 2 plus 5 has to be greater than 4. Okay. And I can go and solve these inequalities. I get 6 is greater than 5. I get 9 is greater than 2. And I get 7 is greater than 4. All right. And now if I want to see if those are true statements, is 6 greater than 5? Yes. Is 9 greater than 2? Yes. Is 7 greater than 4? Yes. So since I got yes for all of those, then I know that these three numbers could make a triangle. There is a shortcut to this problem, and the shortcut is the fact that I don't really need to do all three of these situations to determine a yes. If I just add up the two smaller ones and make sure they are greater than the third side, that's all that I have to do. That's the minimum amount. So if you just want to do that, that is fine. And I'll show you how that works on the next one. All right, on the next one on B, again, if I add up the two smallest, and I just want to make sure it's greater than the third side, which is 14. Well, when I go ahead and add those up, I get 14 is greater than 14. And that's not a true statement. Okay, it's supposed to be greater than, not equal to. So my answer is no. Those cannot make a triangle. It's like it's not long enough to be able to turn it into a triangle. The other thing you could write down here is just a little reminder is that the sum of the two small of the two smallest sides must be greater than the third side. Okay, last question here. So on this one, it says in triangle XYZ, XY is 8. I mean, I'll also label the picture. XZ is 14. And they want me to figure out what this length is over here. Okay, so here's the thing. They're kind of giving us a hint with the inequalities, but basically I can't use the shortcut because I don't know which two sides are the smallest. My choices are 8, 14, and I don't know. And so because I don't know what YZ is, then I can't figure out what the two smallest ones are. So I have to do all three scenarios like it shows here. I can say XZ14 plus XY8 has to be greater than YZ. I can say XY8 plus YZ, we don't know, I'll just leave it as YZ, is equal to XZ, which is 14. So in this case, sorry about that. In this case, I can also plug in for YZ, which I don't know. I know that XZ is 14, and that has to be greater than XY, which is 8. So if I go ahead and solve for those, I can add up here, and I can get 22 is greater than YZ. But I always like to have the variable on the left side. I think it's easier to read and easier to think about. And the point's going to the YZ, so I still want the point going to the YZ. Alligator's still chomping the 22. All right, over here, I need to go and subtract 8 from both sides to get YZ by itself. So I'm left with YZ is equal to 6. I didn't mean equal to, I meant greater than 6. Turn that into a greater than symbol. Okay, and then in my last scenario, I can subtract 14 from both sides. Okay, so I end up with YZ is greater than, I'll try to do it again, negative 6. Okay, now if I think of these scenarios, I want to think where are all these things happening on the number line at the same time. Well, YZ is greater than 6. Those negative numbers don't even make sense for the length of a side of a triangle. It's telling us it has to be some number bigger than negative 6. But it's also saying right here that YZ has to be greater than 6. So where those lines overlap is going to be greater than 6. So I'm not actually dealing with that one. And I can also see that YZ is some number less than 22. So it's a pretty wide range. So I know YZ is in the middle, and I know that 22 is on one side and 6 is on the other side. And that helps give us a range. That means that any number between 6 and 22 works to make the lengths of the sides of a triangle, but any other number outside of that range does not work. So that is what we're looking for. That is called a compound inequality. All right, let me know if you have any questions.